Hey guys, welcome back to the last episode of Introduction to Computer Networks at NTU. Right, and as you see, just like many of the Wednesday sessions, we don't have many to say, and we can go ahead and start with the topics. All right, and by the way, good morning, Katie. Guys, we're now talking about BGP, the real internet routing at the higher level. Okay, so this BGP routing is very important. And yesterday we started saying that, well, it's pretty much like distance vector, which we all know. You guys know very well, okay, based on how you guys did the quiz on distance vector. And but there's a little difference, right? We now record the entire path instead of just the cost to the destination. Okay, and BGP being a routing algorithm at the higher level, okay, the internal routers within a domain will still need to know these paths. So BGP, okay, unlike distance vector is what? An endless loop of 3 steps routing. But BGP is what? The endless loops of 4-step routing. And the extra step is just to make sure that the BGP routers will propagate these path vector information or reachability informations internally to all the intra-AS routers. Okay, good. Sounds simple. And yesterday in the last video, right, we talked about this reachability information, aka the path vectors. It's the most important information these BGP routers pass around, including to the intra-AS routers. Okay, today, we'll see exactly what the path vector or reachability information, to be more general, look like. All right, and it's not so hard either. Right? In distance vector, right? What's in the distance vector, right? It's a vector, right? For reachable destinations out there in the network, we give it the shortest distance we know, right? And of course, the sender of the message will, of course, announce its identity. So the receivers of the distance vector will know that, oh, if in case I discover a better path, the next hop will be the sender of the distance vector. All right, so recall that. Now distance vector, right? So we'll still have a vector, and it's indexed by the reachable destinations. But in BGP, who are the reachable destinations? They are not individual machines, right? They are individual domains. Therefore, in the vector there, we have the as index is the what? The prefix, the network prefix, the network prefix of a domain. Okay, and then of course you send the attributes for the BGP routers to determine whether to import or export, right? The policy, the routes. But the attribute is no longer just the minimum cost; it's now the path vector. In this video, okay, about 4 minutes, about 4 minutes, slightly longer than 4 minutes, you will see that it's not just the path vector there being the attribute to determine whether you import the policy or export the policy. So if you think about it, in BGP, the logic there, okay, deciding which BGP path to export is essentially the computation that is done. Okay, it's just that in path vector in BGP, it's no longer the Bellman-4 equation there. It's actually defined by the administrator of the domain. All right. So 4 minutes and 15 seconds, you will see that there's more attributes, not just the path vector. There's something called next hop, and in fact more. Okay, for the router to decide, okay, how to import and how to export. And as Polly mentioned earlier, it's determined by the administrator. So it's not a strict algorithmic process. It's pretty much a policy based. There's still like a lot of if else commands, but no longer like a loop, and there's a equation there helping you to decide which is the best route. The best route is based on a bunch of these if then else conditions. All right, so it's still a computation. There's still a computation logic, but that logic is a little bit messy, ad hoc. Okay, depending on what the administrator is the best for the company or for the network. It really depends on the philosophy of the domain. All right, good. So 4 minutes 15 seconds, but this video is very important.
Let's say more about the messages we exchange in these BGP sessions. So these messages are essentially pass vectors. Inside the pass vector, we have lots of these pass entries, okay, or route entries. Each pass in the pass vector of BGP is this: the destination address. Now, because in BGP we are sending packets to a destination network, therefore, to address to a destination network, we use the prefix of the destination network. And then attributes. Now, in pass vector, the most important information there is the path. Therefore, you see, okay, in the set of attribute here, we need to definitely have the AS pass. So AS pass is the most important component in the set of attributes. There we see the list of ASs, okay, it takes from the source to reach the destination. The discovery of the list of ASs, the discovery of the AS pass, however, okay, came the other way, from the destination network. Okay, so the destination network is going to advertise its prefix, okay, and so that's going to be in a advertisement message. Okay, so the home AS of the network X, okay, let's say AS3, okay, receiving such an advertisement at the gateway router, okay, that gateway router is going to prepend itself. Okay, prepend the AS number, okay, AS number 3, okay, before X, and send this out as the prefix advertisement to the neighboring AS. The neighboring AS, let's say AS2 there, receiving such, okay, an advertisement, it's going to prepend itself before it sends out further to AS2's neighboring AS. Okay. So now AS2's neighboring AS receiving such an advertisement will then discover, right, a path to go from AS2, AS3 to destination X. Okay, so list of ASs through, okay, these paths, the prefix advertisements as traversed. Okay. So that is the AS path. One of the most important, okay, part in the attribute set. Second important is this, the next hop. Now, this is not quite, okay, the next hop AS, the next AS number, okay, in the AS path. No. It is actually the gateway router, okay, within the source AS that is directly connected to the next hop AS. So it's carrying the IP address, okay, of the gateway router, leading to the next hop AS. So the two together necessary forming the attribute set. BGP routing, okay, has grown more and more being policy-based, okay, meaning the gateway router, they're receiving these prefix advertisements, okay. It's not like for every advertisement, they will actually prepend its own AS and then pass it down further to other neighboring ASs. There'll be some sort of import policy, okay. So the gateway there receiving the advertisements will have to say, okay, will have to decide. Some of the advertisements they will decline, and some others they accept. Only the ones they accept will be propagated further to all the routers within the AS. Okay. Now the gateway routers, okay, in the AS receiving these accepted, okay, advertisements will then decide whether to prepend themselves and then pass the expanded advertisements, okay, to the other neighboring ASs. Okay. But you see, there are also policy, okay, the AS might apply before these other gateway routers, okay, advertise the expanded, okay, AS path to the neighboring ASs. Okay, so some of them actually might have complex policy that is very fine-grained. For example, if one gateway router, okay, connects to two other neighboring ASs, this gateway router might say, I send this particular extended advertisements only to one of the ASs. Yeah. Policy to import and policy also to export.
All right, now you get a better idea how BGP is like with that video. And that next hop attribute, we're going to talk about that a little bit more. It's actually more important for the intra-AS router to decide, okay, which gateway router to send the data down to the particular prefix, network prefix, particular destination domain. All right. So it's not quite to decide which policy to import or export. Okay, so you'll hear a little bit more. Now, next are easier. We'll show two examples with illustrations of these AS pass messages being passed, and some of the paths are imported, some of the paths are exported. Okay, two examples. The video is again 4 minutes 15 seconds.
Let's go over a couple more examples so it's more clear where the import policy and the export policies are applied. So this is the same example we saw earlier. Destination network is here, X. Okay, and so AS3 there is gonna send the pass advertisement. Okay, that looks like this: AS3, comma X. Okay, and this is gonna reach 2C of AS2. So AS2's router 2C receives pass advertisements like this. And this is through the exterior BGP connection. And the advertisement came from AS3 and from router 3A. So 3A of AS3. Now, if you recall in the very early slide, right, the border router here will then propagate the AS path throughout all routers in the network. But now, there's import policy. So, the exact process is more like this. 2C there will actually check AS2's import policy. If the policy says 2C, it's okay to accept the pass, then 2C propagates the pass to all routers internal of AS2. So sending of these AS pass internally is through the interior BGP connections. All right, so the import policy actually happens before the propagation of the pass, okay, to all the routers internally. And then, 2A here, receiving such a pass, can then prepend itself and pass it further to the neighboring ASs. But wait, the export policy is applied here before passing on of the advertisements. Let's check. If 2A here is allowed to advertise the discovered pass to AS1 here, then we form the new advertisement AS2, AS3, and X, and then send it to 1C that belongs to AS1. So once again, before the prepended, the extended AS pass can be advertised further to the rest of the internet, we check the export policy. Right? Second example is a bit more realistic. So 3A here, the gateway router of AS3, might have multiple eBGP connections to outside. So in that case, a gateway router might learn multiple paths to a destination in AS3. So let's see. One of the paths is this, right? AS3's 3A sends AS3X as an advertisement to 2C. 2C checks the import policy and therefore pass it on to all the routers internally. 2A picks it up, checks the export policy, and let's say that it's just allowing advertisements of the pass further. So prepend AS2 to the pass and then send it further. At this point, 1C learns the pass AS2, AS3 to destination X. And the way to go is for 1C to send to 2A. The other direction is this. 3A can be simply sending what? AS3X, this past advertisements directly to 1C, and 1C will just simply learn, right? There's another way to reach destination X, which is just simply sending it to AS3 through 3A. So these are the gateway border routers that 1C send the packets to, for the two different paths, 2A and 3A. At this point, 1C sees two advertisements coming in. Before 1C propagates any of the paths further, it needs to check the import policy. So AS1's gateway router 1C there, we need to choose. It could choose one of the two, or it could just take both of them. Let's say that 1C chooses AS3, X. Sure. The shortest AS path. And advertise it to all routers internally of AS1. Okay. This is the second example.
All right, so that's the second example. Next, the topic is called BGP in detail, but what we meant is going one level down, right? So previously we've talked about the routing part, but if you recall, back when we were talking about link state routing, right? We do the Dijkstra algorithm. We can develop the full table, but what's more important is, hey, what is the forwarding table each of the routers would end up having? So that is essentially for each destination, what is the next hop, isn't it? Okay, which interface to forward the packets to next? Okay, that's back in chapter 4, isn't it? So the next video talks about, the next couple of videos talk about how we set the forwarding tables. Okay, particularly within all the routers, okay, of a domain, so including the intra-AS routers. Okay, so the first video here is about 3 minutes. Okay, about 3 minutes. It's essentially an example, right? At the border, okay, the gateway routers receive AS pass. Okay, this AS pass will be passed through the IBGP sessions to the internal routers. Okay, now how does the router decide what is the outgoing interface? Okay, for packets going to that destination network. So that is what this video is about. Again, about 3 minutes.
Let me borrow example 2 here and continue to talk about this. How a router sets up a forwarding table entry, okay, for a destination outside of the AS. Okay. Yeah, scenario the same, destination being X. 3A, the gateway router of AS3 has 2 eBGP connections, therefore 1C here potentially can receive 2 AS pass. And 1C, according to example 2, chooses the shorter AS pass. So let me run the animation. So 1C discovers 2 pass and picks the shorter pass. Okay. And this shorter pass is further propagated internally to all routers. So 1A, 1B, and 1D will learn about the shortest path to destination X from 1C. Okay. And what 1A, 1B, and 1D will do is, well, if I receive ever any packets with destination X, then I will forward the packet towards 1C, the border router, okay, they receive, okay, the AS pass from. Okay. Now, to make it easier to explain what's coming up next, let me just label, okay, for 1A, if the packet is supposed to go out on this interface, then we call that interface 1. And yeah, for packets to go out on this other interface, let's call it 2. Okay, similarly for 1D, this is interface 1, this is interface 2. Now, 1D here, okay, has discovered there is a path to destination X that is going through 1C. Okay, that is what 1D knows so far. To add an entry into the forwarding table for X, 1D needs to know exactly which interface, is it 1 or 2, that leads to 1C. How would 1D know that? Yeah, call the intra-AS routing there. Okay, let's say it's OSPF. Okay, so OSPF is going to tell us if the destination is 1C, what is the link, okay, along the shortest path to 1C. Okay, so that happens to be 1, so we will fill this entry here. Okay, interface column being 1. Similarly, let's try to derive again for 1A. Okay, so 1A knows, for destination X, I should be forwarding packet towards router 1C. So let's call intra-AS routing and find out from OSPF, what is the shortest path to 1C and which link, is it 1 or 2 on the shortest path? And we'll get 2 here, and 2 here with 4 packets to 1D. And 1D here we see earlier will be forwarding packets over this direction and reaching 1C. Therefore, going backwards and reaching destination X.
All right, so with that video, can you see why we need next hop? Isn't it? So when the internal router receives the path vector, is seizing the attribute next hop. Who's the gateway router? Therefore, calling the intra-AS routing to find the next hop to the gateway router. All right. But guys, that was the easy case. Okay, let's check out another case, which is a little bit complex, where you have multiple gateway routers reporting AS pass internally to a intra-AS router. In that case, how the intra-AS router determines the outgoing interface to a particular destination is very interesting. That has actually a specific term called the hot potato routing. Okay, so this video a little bit long because it's a little bit complex. 5 minutes 40 seconds.
Route selection. Now, this mechanism is necessary for slightly more complicated scenarios. Let's go back to example 2 again. Right? We have this router 1C being the gateway router of AS1. So you see towards the end of the scenario, AS1 discovers 2 AS paths, one from AS3 to go to destination X, the other from AS2, and then via AS3 to go to destination X. So in the previous slide, we say the policy of AS1 is such that we only select this to import. And so 1C propagates this AS path to all internal routers. Internal routers will then send packets, destination being X, through 1C and therefore being forwarded to AS3. Very simple. But what if we relax the import policy a little bit further so that 1C here cannot discard this other AS path? As a result, 1C will need to propagate both paths internally. So each of these routers internally will see more than one route to the destination X. Ouch. Yeah, so that's when we apply the route selection. So internal router there will need to apply route selection here to decide which of these two it will send packets to. The process is like this. Step number 1, check the local preference of these routes. So if you recall earlier, a route is what? Composed of the destination network's prefix and a set of these attributes. So we know that AS pass is one attribute. Next hop is one attribute. There's one more attribute called the local preference. So this one actually weighs the highest. So BGP actually checks the local preference first and take the path with the highest local preference. So local preference there is usually to indicate, between the two neighboring ASs, AS3 versus AS2, does AS1 prefer forwarding packets to AS3 or AS2? So if AS3 is preferred, AS3's path, so this guy here is going to carry a higher local preference. Now, if there's no local preference specified, then we go to step 2. So the internal router, let's say 1D here, will then check which of these multiple paths to destination X give us the shortest AS path. So in the scenario, 1D is going to pick this one. Now, if both AS paths have the same path lengths, then we go to step 3. We pick the closest next hop router. 1D here sees 2 paths. The next hop router for this path is going to be 1C. The next hop router for this path here is going to be 1C as well, because 1C is the border router receiving these advertisements. But if you consider a slightly different scenario, so again, we have AS3, AS2, and AS1. So the router now in the limma is now 2D. 2D here actually sees 2 AS paths. One AS path is actually coming from 2C. 2C is the gateway router connecting to AS3, which it receives a path to X, AS3, X. 2A is the gateway router connecting to AS1, where AS1 is passing another AS path to AS2. That is AS1, AS3, and X. So 2A pass this path to 2D. 2C also pass on this path to 2D. So 2D in the end learns, there's one AS path through next hop to A, this guy. There's another AS path through 2C, this one. 2D here Okay, assuming that abandon the shortest AS path phase, go straight to the closest next hop router phase. Then we'll do this. For this pass, next hop router is 2A. For this pass, next hop router is 2C. 2D here will consult, okay, the intra-AS routing again to find out is 2A closer or 2C being closer. So if you see the scenario, 2A distance to 2D is only the link cost between 2A to D, which is 201. Distance between 2D to C, however, is 263. So 2D here is going to choose 2A to forward the packets to. So it's going to choose AS1, AS3, and X, this other AS pass, which is actually longer, okay, than this other one to pass the data. This is also very well known as the hot potato routing. Allow me to explain. Yeah, so 2D is this guy holding a hot potato. So yeah, the packets are almost like these hot potatoes, and 2D can't wait to get rid of these packets. So 2D wants to be able to pass the hot potatoes, the packets, as soon as possible. Therefore, picking, okay, this poor guy here, 2A, to throw all the hot potatoes over. Okay, distance is shorter. Okay.
All right. Okay, so hot potato routing. And those who pay attention to the video, right? Polly said that, hey, here's first criteria, local preference, second criteria, AS pass, and then the next hop. And that's what Ivan was asking. Okay, so good bridge there, Ivan. You know what? Nowadays, as Polly mentioned also yesterday, right? Two AS domains versus one AS domain. Hey, which route really is shorter? You actually don't know, right? You could have a huge domain that is super large. Then the delay it takes to go over that AS might be longer than the delay going through two small ASs. Okay, so in practice, people most of the means don't actually look at the AS pass length anymore. And therefore, we go straight down to do hot potato routing. All right? So internal AS router would just simply judge, right, which of the gateway routers that has reported valid path, okay, is the nearest, okay? You don't know what is the optimum, right? So what do? You do the local minimum. You don't know the global optimum. Therefore, you try the local optimum. Guys, makes sense, isn't it? And you know what? It's perfect timing. That's exercise hot potato routing. So this is quiz 49. And yeah, you know what? The scenario look familiar, right? It's just like the example we saw describing hot potato routing, except that Polly has added one link here in between 2A and 2B. All right? Scenarios completely the same. So once again, we ignore that the internal routers will choose an AS pass based on the AS pass length and simply determine it based on hot potato routing. All right? So 2D, again, is still sending data to X. So 2D here, sending data to X. And 2D learns through IBGP sessions that there are two routes, okay? And one is through 2A, one is through 2C. So one is over here, the other is over here. Which router would 2D send the data to next? Okay, so which router? Okay, so there are actually, yeah, these three routers being potential candidate, right? Q2, which AS, okay, would the data go next? All right, after leaving AS2, which is the AS the data will go to next? And guys, let's go to the score space. If you go to channel, interesting. Somehow. Okay, guys, I know you guys know where the channel is. So let's go to week 15 quiz 49. Yeah, I see you guys doing it already. But let Polly configure. So guys, You have 2 more minutes. Okay, so let me play the music there. Okay, you guys work on it, and Polly needs to fix the Stream Deck setting here. Yeah, I guess it's straightforward, right? After following the video. Yeah, you just try to find whichever gateway that is closer to get to, right? Good. So I see that Katie here, be more specific, showing exactly the route, right, to the gateway router 2A. And Yu Zheng here says more. Yeah, because the cost to 2A is less than the cost to 2C. Well explained. All right. So some of you guys might find it interesting that Polly kind of prefers students telling the process, okay, your thinking process, because of course that's one way that is easier for Polly to see whether you guys really pick up the idea. But you know what? Writing it out, it's actually helpful for yourself, isn't it? If you can explain to other people how it works, then you're sure that you get it. If you cannot explain how things work to others, how do you know? Right? Hey, your brain can, cheat you from now and then, every now and then. So, yeah, if you can explain to others, then you know for sure. All right, very good. So, hot potato routing, it's actually not that easy to understand, but I'm happy to see that you guys pick things up. No problem. And let's move on, okay, to the next topic. Okay, one more detail that we need to disclose is, hey, exactly how these BGP messages look like. Okay, in BGP, of course, we send this reachability information we call pass vector, which you know that even though we call it pass vector, but it's actually more than just pass vectoring it. Okay, but you know what? Hey, we need to maintain these iBGP, eBGP sessions, right? So to create these sessions, there are also some control messages around we need to send from BGP routers to other BGP routers and also to internal routers. Okay, so there are several messages there defined in the BGP protocols. So this is what the video next is about. And this one is brief, 2 minutes, 15 seconds.
This is the last slide of the BGP protocol. Okay, so in BGP, the protocol, it actually defines 4 types of messages. Okay, so not just the message we mentioned earlier containing the pass factor being passed in the BGP sessions. There are other types of messages that BGP sends. So some of them are actually to send the pass advertisements, to send the pass factors, but some of them are to establish the TCP connections, okay, for the session, or to tear down the TCP connection, or to keep the TCP sessions alive. Okay, let's go through these BGP messages. The first type is called the open message. Yeah, the first purpose of it is to establish the TCP connection. Okay, so the sending peer there will be sending an open message to the receiving peer. Okay. Receiving peer will be sending back an ACK for that message. As a result, the two peers establish a BGP session. So the ACK of the open message there is going to be in the keep alive message format. Okay, I know it's a bit tricky. Now, the open message is also used to do the authentication. Okay, so the two peers can authenticate each other to make sure that the pass advertisements, okay, are indeed the true pass, okay, to be discovered. Now, update message. So this is the message being used to send the past advertisements, the pass factors. So this message is also allowing the routers to withdraw outdated pass factors. Keep alive message we saw earlier, it's to ACK the open message to establish a TCP connection. Keep alive message is also being sent, okay, periodically to refresh the TCP connection, just in case there's no update messages being generated. So update messages is the past advertisements. Last is the notification message. Okay, so this reports in case there's any error in the previous message. Okay, and it's also used to close the connections for peers.
All right, so 4 kinds of messages. And if you paid attention, you will see that 3 of the messages are just to maintain the connection, right? So one is to open the IBGP or eBGP sessions, the other to close, and then there's also a refreshment. So you don't want to keep these connections persistent. Recall back in chapter 2. So you keep TCP connections persistent so that you don't have the connection setup delay. Okay. Recall yesterday I asked you guys, right, whether you would prefer doing the PV, pass factor announcements, or reachability information through UDP or TCP or TLS. Hey, some of you say UDP because, hey, there's no connection setup cost. Yeah, but you see, guys, keeping the TCP connection persistent is another way to cut the establishing time, right? Connection establishment time. So guys, a lot of times it's not, the options are never really binary. Sometimes you see, hey, you choose both, right? And you use it in combination such that it works the best for the problem at hand. And that's very often how the real world works. Okay. And speaking of real world, Yixing was asking, so the inter-AS, so guys, go to the live chat. So the inter-AS routing is only policy based without a top level routing algorithm? Question mark. You know what? It is now. Okay. Polly actually said that, hey, no, there's no Bellman-4 equation there. Okay. And if you recall distance vector, every router implements the Bellman-4 equation. Okay. In higher level, BGP level routing, there's no Bellman-4 equation. Okay. Polly mentioned that it's more like a bunch of if-else condition. And you know what? These bunch of if-else conditions could also be very different from one domain to another domain. And guys, isn't that how the real world is like? Right? Some companies are thinking more for public interest, their policy could be different. Some companies thinking more for $, the policy obviously will be different. Okay. Can you say that, hey, you guys, whichever ISP, as long as you're ISP, you guys need to follow the same metric? nah. Why? Right? Just like when Polly says, hey guys, you want to submit your assignments in time, but hey, do all of you follow the policy? No, that's the interesting part of the real world. So I know you guys are all engineering or science major, but think again. Open up your mind. Hey, summer is coming. How about reading a couple books outside of your domain and see a little bit more what the real world is more like? It's very often, right? Living in the EE department or computer science department, whichever departments you came from, but mostly science and technology. We calculate. Okay? We have metrics. We quantify things. But in real world, there are many, 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 many things you cannot quantify, and it's super hard to quantify. Okay. And you will run into situations like that definitely in the future. How do you deal with that? Are you comfortable dealing with the problems like that? Yeah, that sounds hard. You know what? Hey, BGP, compared to that, is still simpler. All right. And we'll talk about, yeah, the more complicated part of BGP, which is this policy. Okay. It's very general, but there are still some principles one can follow. All right. And so this video here, okay, talks about the basic policies. Okay. If there's not a route, okay, if there's only one connection there is, of course you need to announce the existence of your customers. Okay. If there are multiple ways, then you can potentially choose one way or another to announce the existence of your customers. Okay. So when I'm saying existence of your customer, I'm asking you guys to think like an ISP. Excuse me. Because a domain that is really in charge of announcing these reachability informations are always the ISPs. And we as customers of these ISPs, of course, announce our existence, but they would need to further propagate the existence. So our ISP serves a very important role. Or now if you think you are an ISP, you play a very important role. You need to tell the rest of the world that your customers exist. Your customers are reachable. Okay, so we're going to talk about thinking like an ISP, how you announce, okay, reachability informations and how you propagate reachability informations further, because you could be an intermediate ISPs for other ISPs. So this video, you want to pay attention. It's a little bit long, almost 7 minutes, but it's very important. Okay, so we'll play this video and then take a break. And when we resume the lecture, there's a series of quizzes. So quiz 50 to 53, okay, to make a point so that you guys can exercise this idea that the real world is more complicated. And you will see for sure that between you guys, just within you guys, you might decide to pursue different policies. Okay. All right, so let's play the video. 6 minutes, 44 seconds to be exact.
One very important issue about BGP to discuss here is, BGP routing is very policy-based these days. If you recall, there's import policy, there's export policy, there's also local preference for route selection. Yeah, there are lots of things the network admins can tweak, okay, to decide where packet goes. The reason for those policy-based setting is this. Let me use an example to explain. Consider this network. We have 3 ISPs in the middle, ABC, they are the provider networks. W, X, Y are the customer networks. More specifically, W is the customer of ISP A. So W pays A some amount of money every month, and A will in turn help W passing packets, okay, going out to the rest of the internet or coming in from the internet. Similarly, if the traffic is supposed to go out the other direction, all right? W pays A, and therefore A is responsible to serve W. Similarly, for this customer-provider pair, Y being a customer, C being a provider, X being a customer, B being a provider. Now, X is a little bit more complicated. It's multi-homed, okay, customer network. So X here pays B and C. Okay, as a result, B and C should both be forwarding packets for X. In scenario 1, let's assume that there's a user in customer network Y here wanting to send something to the user in W. And so in order for W to draw in traffic from the internet, its provider A here will need to announce its existence. So AW here, okay, an AS pass needs to be sent to the neighboring ASs, which happen to be ISP B and ISP C. Okay, so A advertises pass AW to B and to C. As a result, okay, B is going to see this pass, okay, and prepend itself, okay, and see if this AS pass needs to be further advertised to yet another neighboring AS, such as provider C. Now, B's network admin actually knows better and choose not to do that. And the reason for that is because of this. If BAW is advertised to C, C is going to discover, this is actually one way for this user in Y to send traffic to user in W. And therefore, the traffic is going to go this way to W. And you know what? B here, okay, B does have a customer X. X is paying B. But is W paying B? Is A paying B? Is C paying B? Well, based on the setup of the problem, WAC not paying B, and yet B is using the network resource here to transit the traffic for B and C. Okay, so B gets no revenue to do this route, BCAW, because CAW, based on the scenario setup, not paying B. Okay, so chooses not to advertise BAW to C is so that C does not discover this pass, and therefore, okay, not using this pass to send traffic. Instead, C here receiving AW is going to prepend itself CAW, and Y is going to use CAW as a way to send traffic to the user in W. So you see, in this scenario, very obvious. For a customer network, ISP will be happy to route traffic to and from the customer. Okay. But the ISP not getting paid by others would hate to transit traffic between these other ISPs. Okay. So bottom line, not getting paid for the work. Scenario 2 is very similar to scenario 1. The network is completely the same, and we just continue scenario 1 from here. When B has discovered BAW is a pass to go from B to W. Now back in scenario 1, a min of B chooses to not forward BAW to C, okay, so that we don't draw traffic this way. Nice. But B will actually have to send BAW to X, so X can discover XBAW is a pass. So just in case there's any user in X wanting to send data to user in W. Nice, so makes sense. But hey, X is dual home, so there's yet another connection to a neighboring ASC. So should the network admin of X here send XBAW to C? Well, let's assume that we send XBAW to C. In this case, C is going to discover CXBAW is a pass to send data to W. Similarly, Y is going to discover YCXBAW is a pass to send traffic. YCXBAW is a pass to send traffic from a user in Y to a user in W. And that's going to travel like this. How do you like this? Well, from an X's network admin's point of view, hey, this traffic is actually not for me at all, right? It's actually between Y and W. Y pays C, W pays A, and no one is paying me, and yet I'm paying B and C. Okay, so it's a big no-no for X here to send X, B, A, W to C. All right, so X will not want traffic coming from C and simply transiting to B. So X should not be advertising anything to C, okay, coming from B. So again, money is the issue, all right? So X is not getting any money from C or from B. Therefore, X is not happy transiting traffic for these other ISPs or even from other customer networks not paying. Okay.
All right. So from the video, I don't know if you guys pick these up. There are two more principles. One is what? A provider domain, okay, will not pass the AS pass. That doesn't concern its customer, right? Because they are not obligated to. And that if they do, then they might end up of transiting traffic for other people's customers. So it doesn't make sense, right? Because these ISPs will need to make a profit to sustain. Okay. The other principle is a customer domain. Okay, people who pay ISPs to get internet access, the customer domains, don't forward the AS pass at all, because that only draw traffic into the customer domains. Okay, and that is not. Customer domains don't make money. Okay, they actually pay money already, right? It doesn't make sense to sort of allow other traffic to transit through them without getting any benefits. All right, so two other principles. And there are actually many other principles that are very sort of region dependent or business dependent. Okay, so that's what the quiz 50 to 53 are about. So let's take a break. It's now 11:12 and we'll resume 11:22. Okay, so break. All right, so let's resume the lecture. And in fact, what we'll be doing are to go through quiz 50 all the way to 53. So let's start from the first one. Okay. Yeah, so this is 50, and this is the easiest one. All right, so what I'm asking you is this. Yeah, we do have a network, which is very much like the examples we covered in the 7-minute video earlier. Okay, we have 3 ISP domains, so these are providers. And we have 3 customer domains, okay, X, Y, and W, okay, in small circles. And let's assume for all the quizzes coming, Y sends data to X. Y sends data to X, okay? Therefore, X needs to announce its existence, the reachability information, of course, right? First to the ISP, and ISP domain then will need to, append itself and then announce the path further down this way. All right, so that's the basic setup. Okay, and this is a tree network. So, yeah, so there's no cycle, okay, anywhere on the graph. All right, so X here is the customer. X here is the customer. X pays B. That's how one defines the provider-customer relationship, right? And B is the provider. B's responsibility, okay, by receiving payments from X, promises these: forward traffic in both directions, from X or to X. So B here will need to forward traffic from within X to outside, as well as forwarding traffic from outside back to X. So you see, the promise is bidirectional. All right, good. So setup is complete. Now, the real question is, should B advertise the AS pass BX to A? So X announces its existence. X will arrive here. B would append itself. And should B announce this AS pass to A? And why? Q2. Should A advertise the AS pass ABX to C? So in case B decides to send BX to A, right? So BX will arrive here. Should A append itself and announce the existence to C? All right, so these are the questions. What's more important is to tell Polly why. So let's go to the discourse space. All right. There, I see. Yeah, team 18. Yes, it's necessary. Yeah, because that's only path, right? If you don't announce BX to A, X is isolated entirely. And hey, you promise X to forward traffic, okay, either way for X. All right, so in order for X to receive traffic from Y, of course. Okay, now A receive a pass BX, and A has 2 connections. Okay, but one of the connections is used where we receive BX, right? So A has only one other connection remaining. Okay, in order for B to be able to tell other people its existence, A will have to, because A is the only one holding the resource, allowing the entire B, okay, part of the network to let the rest of the network know. So A, yeah, definitely need to. And A is obligated to do that, okay, promising being a part of the internet, okay. So at least you allow, okay, people connecting to you, at least one connection to the rest of the world. Okay, so in a way, B could be, okay, a customer of A. Okay, but we don't know exactly whether A is the customer of B or B is the customer of A. So it can go either way. All right, so yes, without the advertisements, X will be isolated. Very good. All right, so as Polly said, this is the easier case. So only pass. Good, guys. Yeah, so as you write the reason now, it helps. It helps you to understand the problem. Okay, and sometimes you discover the complexity of the problem. Okay. to guarantee X is not isolated. Yeah, because B promised to be the provider. Okay, and B is taking money for it. Okay, otherwise you lose X. B will lose X. Then what is the purpose of being a provider then if you don't have customers? Okay, so think more and more and more, and then you will know that obviously B will need to announce BX. A, however, is a little bit complex. A is not the customer of X, and from the AS pass attribute in the reachability information, in the message, in the pass vector message, right? A will see, okay, the end is X, and X is not my customer. But in the video previously, the 7-minute video, right, one of the principles is that I can check the AS pass, right? If the eventual destination is not my customer, I mean, one can choose not to forward the AS pass. I mean, hey, not my customer. But should A announce it? Usually they do, right? If this is the only way. Yeah, B could be A's customer. So I see Felix says A is a provider. It's not necessary. Yeah, as we can see, the global topology, right? Yeah, A should be sending ABX to C. But Felix is also right. Team 9 is also correct. There's nothing wrong with this, right? One of the principles we've talked about is, okay, BX. A would think a little bit, right? With BX and X is not my customer. I can choose not to forward it. Okay. But AC is the only way around, right? If I don't announce BX, we don't know if B has other alternative paths. Okay. But globally, we see that it's the only path. But Felix is also right. You just don't know, right? There could be other paths. In fact, on the internet, many of the Bs have multiple connections, or ABCs, the providers often have multiple connections. Yeah, guys? Yeah, when you say yes, B should forward ABC to C. I know, I understand, okay? Because it's the only way. That's because we see. But on the internet, we don't really know. We don't really know. Okay, Zheng Nian, very good. You're following the video. So only differences between those who answer Q2 yes versus no is whether you are thinking like a router or thinking like, hey, you can see the whole network, thinking like God. All right. So as the administrator of A, do you know? Usually you don't. So what should you do? You just don't know, right? Yes or no? Yes or no? Yes or no? Yes or no? You see? When it comes to working well with the world, right? How do you know, right? In other part of the world, how it works, how things work there, right? You don't know that well. Okay. All right. You see, it's not that the poly tries to be nice and interpret your answer in a way that so that you feel better. No, it's very often the answer, again, not binary. It really depends on your perspective. See? And it's completely fine that some of you stand on this perspective, some of you stand on other perspectives. We all have our own perspective. What's wrong with that? Nothing is wrong with that. We are we. Okay, you are you. Polly is Polly. Okay, Polly talks in a funny way, but hey, okay, Polly learned talking this way maybe because of many other inputs. Okay, other influences. All right, good. Now you see, okay, Q2 start getting a little bit complex. Okay, and you will see that hey, you don't need to follow whoever else says. You don't have to. Why? I think Polly think that following what other people do is one of the solutions when you don't know better. But when you don't know better, you still have the choice of hey, right? Wait. Give me some time. Okay, let me figure this out before I say yes or no, or I pick this or that. Isn't it? Isn't it? Okay. So when I see some of you sticking to your own perspective or going extra steps to come up with the interpretation of your own, I appreciate that. Polly appreciates that very well because to tell you the truth, that's also part of growing up. Instead of doing everyone else is doing, okay, that's actually an easier way to get around the problem, but that is also a mistake that people make very often. If the one you follow makes a mistake. Yeah, so and you're not quite sure, then you follow the majority opinions. But are you sure the majority is correct? Yeah, so I'm sorry, guys, because of the topic, it's policy, which means there's no formula behind it. There's no formula behind it. So Polly needs to talk again a little bit more generally, all right? So guys, I know it can be a little bit troublesome for some of you because you're not used to deciding without a metric that you can quantify. All right, good. I kind of make you uncomfortable now, but hey, that's such is life, okay? And I think it's better that Polly makes you uncomfortable earlier in your life than later. All right, good. So, guys, let's go on to Q51. Okay, now this time, it's no longer a tree, right? So you see complication. So let's go to the this bulletin board, to the whiteboard. All right, so this is 51. We now have a cyclic network, all right? And this is a cyclic network scenario 1. Okay, so there are 3 of these. All right, and B advertise BX out. So this is the presumption. So X is still the customer of B. Okay, so all the setup are the same as Q50. All right, and B has already announced BX. Okay, and but to who? Right, because there are 2 ways out. Okay, or 2 ways in the meantime. Good. So Q1 asks, right? A and C charges B equal amount of money per bit. So with this statement, with this condition, we know that A and C are both provider of B. So A and C are higher tier provider. And B, although a provider of X, B are actually customers of A and C. Okay? Now, A and C charge B equally. Okay, so there's no difference. Now, your perspective, guys, your perspective is B. Thinking you're B. Okay? Would you advertise BX only to A, only to C, both, or at least one of the 2? All right, so justify from your perspective. So this is an easier case. Q2. A and C are still providers of B. Okay, but this time, C charges B more per unit traffic. A, more affordable to B. So if we look at the money flow, it will look like this. Oh, B needs to pay C more, and B pays A less. Okay, thicker error, thinner error. Okay, so and this is the money flow. Again, your perspective is still B. All right. Should B advertise BX to A only, or to C only, or both, or at least one of the two? Okay, again, what's the matter is to justify why. All right, guys, you guys have 5 minutes to think this through. Let's go to the Discord channel quiz 51. All right, 5 minutes, take your time. very good. Okay, let's walk through a few of your solutions. So Team 7 says, okay, for Q1, either one. Okay, as long as I have a pass out, X will be able to receive data, right? And then I trust the other ISPs will forward the pass further. Okay. And for Q2, only A, same reason. So just send through one of them and see whether the other ISPs will pass the path information further. Okay, so that's a very straightforward thinking. And Team 12 says both and both. Oh, advertising to only one may leave us disconnected. Okay, so very interesting. So Team 12 as B is thinking about reliability for the customers, right? So in the future, potentially they can raise the premium of their customers and earn more. Okay, so willing to sacrifice a higher cost, but eventually providing better service to the customers. So maybe a way to attract new customers, isn't it? Don't we all have experiences like this, right? So we subscribe to this particular provider and it was nice at the beginning, and gradually you find that the reliability is not so high, and then you switch to another provider who charges higher. Okay. B should advertise B to both A and C. Yeah. Because either way, either one of them charge the same, right? And sending to both allows maximum reachability. B should only advertise to A because it's cheaper, right? To guarantee a pass to W. Additionally, there will hopefully be a pass advertised, hopefully. Okay, good. So Katie knows, team 2 knows that there's a risk. There's a risk if you advertise only to one of the neighbors, right? You will need to hope that the neighbor will further propagate the path. All right, advertise at least one. Okay, so this is the minimum requirement. Advertise only to A since A costs less, right? And steering traffic through A minimizes B's expense. Okay, this might be a good idea, right? When B is just starting up, okay, or depending on the capital, okay, behind B. Both A and C. So I see that, hey, you guys have different thinking, and this time you don't mind expressing yourself, right? Only to A. Make traffic enter B through cheaper path. Okay. At least one of the two. Yeah, so this is actually developing further, right? If they send it to only one of the two, right? And you also hope, okay, the rest of the network will do the right thing. What you don't know is still that you don't know if the rest of the world will be thinking generously or selfishly. So if you still recall in the 7-minute video, right? The ISPs in the middle can see, right? If a pass, the eventual destination is not the customer, not forwarding it. And that seems to be a principle. Okay. But maybe more providers learn that that's probably only gonna make internet more vulnerable. Isn't it? If one is selfish, then the people around them become selfish, the people around this selfish small group of people get selfish, and then people around the larger group of selfish people become selfish. Yeah, it's human psychology. I think it's also business psychology. Okay, so I mean, I don't know if you agree. Polly felt that the business school is essentially social science. And I think marketing is already very social science, okay, and partly psychology. All right, so yeah. Let's see. Jordan says B should advertise BX to at least 1. So this is minimum reachability. So guys, don't you guys think that for Q1, right? Advertising to just 1, that's minimum, must have, right? Advertising to both doesn't hurt. Maximize the reachability, and potentially you provide a better service. So sending to both, not such a bad idea, right? So it's a range. At least 1. To both, either way is fine. Sending to no, obviously not okay. So you guys see that, hey, the answer, as long as you're within a bound, a range, then you should be okay. Okay, so Q2, I think similar, right? You can argue either way, but still the bound is that at least 1. Okay, whether the company is making money can be a little bit tricky. All right, good. But I can see that many of you send advertise to A, because A is cheaper. You already lowered the cost, expenditure. Good reason to do that. All right, good. This is the second exercise. You begin to see the complexity, right? When the money factor comes into the picture. Now, let's move on to the next. All right, so let's go to quiz 52. All right, and let's do this. This is a cyclic network in scenario 2, okay? And C is advertising, okay? So we still have money flow here, but focus on this particular scenario. B already advertised BX to A, okay? And A already advertised ABX. So A append to the path and advertises to C. Okay. And you know what? B advertise also BX to C. So hey, BX is here. ABX is also here. So in a way, C here has 2 paths. BX and ABX. All right. Now, given C charges A more, C charges B less. C charges A more, C charges B less. So the money flow looks like this. Suppose your perspective is now C. Would you advertise CABX or CBX only, or both to Y? So obviously, not sending is not okay, right? So we limit the only solution that is just not going to be viable, right? So these are the options. So in your perspective, yeah, which way would you do it and why? Okay, just one of CABX, CBX, or both. So for this one, guys, you have also 5 minutes. Okay, think it through. Okay, and tell me why. All right, so let's go to the score space. All right, so quiz 52, 5 minutes. All right. So yeah, I can see that many of you sees that hey, this is money opportunity. Yeah. Hey, complete normal, right? So if you want to make a better profit, you announce ABX because if traffic always comes through A, you get to charge more. But I see also alternative thinking. Only CBX because hey, Polly has said that hey, A is pass. Very often you cannot tell exactly, right? What's the pass internally within a domain. But ABX and BX, obviously, right? One is costlier than another because it needs to cross another domain A. Okay, so it's not like ACX, then you cannot compare AC to B. It's AB to B. Right? So it's obvious ABX is going to be longer. Okay, so in this case, A is paths are comparable. Right? So BX or eventually CBX to Y is going to be a shorter path. All right? it's a shorter path. Okay, charging A more. Okay. Very interesting thinking from Cheng Jie. Okay, so Cheng Jie was explaining charging A more means that potentially the link between A and C is more expensive somehow. Well, it can be. It can be. But it can also be because C felt that, hey, everyone wants to connect to me, so I can actually charge other people higher. Okay. Or A is just one of the sort of lower tier ISPs, okay, and charge them more. Or A is wealthy, okay, C can deal with A such that charging more, unless A knows about C's deal with B, right? A might still be paying more for C's access. So yeah, so you're thinking, right, deep down, why C charges A more? Okay, very good. But I can see more of you says, yeah, that's advertise only ABX. Okay. And you know what? Traffic going through A, the delay might not be so much longer. Right? Good. So several of you did mention, right? Yeah, that's more money. So Ethan here says, advertise CBX. Okay. The path taken is shorter. Okay. But, so you see that the scheme is a combination. Okay, so basically take CBX or advertise CBX. However, I think, is it C or B? Okay, I think Ethan, you probably meant C charges A more, but only a small amount more. So if Polly's interpretation is right, okay, so Ethan, correct me if I'm wrong. So what I'm trying to explain is that if C charges A more, but by only a little more, right? So it might still be okay to send CABX, okay, because cost-wise is not significantly more. I think this is thinking from A's perspective. So Ethan, let me know if I misinterpret your solution, okay? CABX, most of you are thinking money, definitely. And you know what? This is internet is now a business, right? If you recall back in chapter 1, how the internet grow to its current status. Okay, the structure grow to current status because it becomes a profitable business, and then there are ISPs showing up. All right, good. So I think either way is fine. Whether money is more important or shorter distance, customer satisfaction is more important. Okay, either way is fine. So you see a range of solutions here. All right, now let's move on to the last quiz. Okay, 53. All right, so you will see at this point on the internet, it's still very much a money game. So this is the scenario where you see A is in trouble. Okay, so essentially we continue from quiz 51 and 52. Okay, so it's a cyclic network. Okay, and the money flow is like this. Okay, B pays A less, B pays C more, and C charges A more, and C charges B less. So as to how come, right, the payment being so weird, hey, we don't know how they deal the business, okay, and we don't know either that at what point they make the deal, okay. So if we know for a fact that this is the money flow structure, okay, let me ask. Consider money, Yeah, just like many of you answer for quiz 52. CABX will be the path to forward the traffic from Y to X. But, hey, change your perspective. If you are hired by A, okay, A is here. Uh-oh. B is paying A, all right? But A is paying C a lot more. Right? Hey, it doesn't make sense. If A allow traffic to go this way, for every bit it transit, A is losing money. Ouch. And X and Y are none of them are my customer. All right, so Q1 ask, would you raise or lower the price charging B? Y. Q2, would you raise or lower the price you pay C? And Y. Q3 ask, are there other solutions out of adjusting the payment plan? All right, so this one again 5 minutes. Oh wait, no, we are close to the end of the lecture. Guys, you have only 3 minutes. Sorry about that. Let's go to the score. Channel quiz 53, 3 minutes. All right. Okay. Sometimes Polly take while answers because, it's fun. Okay. And guys, having fun is important. So let's see. Team 18. Team 18 says raise the price, charging B, lower the price, paying C. So this is obvious, right? In order to balance, right? And reduce the deficit. But after that, right? Raise the price, charging W to make more money, okay? To further, okay, lower the deficit, okay? Yeah, but I'm not quite sure whether W is going to be happy though. Team 18, right? 博元. But you know what? That's a solution, right? Because, in the business world, the deals are often hidden. You don't know. Transparency. In business world, everything is a secret. There's a reason. Yeah, because you don't know you're paying more or less. Okay. And be easier, okay, for your provider to adjust the payment plan. Raise charging B and lower charging C. Good. So for Q1 and Q2, the answer are obvious. We're now paying, so we should profit. Okay. Okay, so Chengjie, I'm actually not quite sure what your answer for Q3 is. Okay, but I can see, yeah, the reason for Q1 and Q2, your answer to Q1 and Q2, that's clear. Okay. And Team 22, Vincent, stop advertising ABX to C. Oh, so this is a technical solution, isn't it? Yeah, so you can actually do it the business way, try to balance the deficit, but you can also do it the technical way. So hey, A, you own your domain, right? So you can actually stop advertise ABX to C. Then hey, C won't be able to get traffic through you, right? And there's still a pass CBX. Good. So yeah, this is indeed an alternative solution and a technical one. Okay, let's see. Yeah, teams 14 discover also there's a technical solution to this problem. So what do you think? If you are A, would you prefer the business solution or the technical solution? Yeah, in previous semester, I've seen people saying, hey, let's use game theory. But you see that game theory can get complicated in case you only have local information, isn't it? And it'll be a selfish game all the way until everyone loses. All right. Okay, guys. You know what? Happy to see that you guys come up with alternative solutions. And for some of you guys, you might want to think a little bit more for quiz 53. It's not so obvious. Take your time. But that's close, okay? BGP. And so that we have a closure of chapter 5.4. So you guys will all be ready for exam 3. So the last video, sorry that we need to go a little bit longer today. This last video is a summary, okay? Or a complete review of BGP. It's brief, only 1.5 minutes.
Now the summary slide. So internet routing is hierarchical. At the lower level, intra-AS routing. At the higher level, inter-AS routing. Now there are 3 very good reasons for such separation. Okay? Because at the higher level, okay, the network admin would really like to be able to block transit traffic. So doing policy-based routing allows admins to do things flexibly. In the intra-AS, however, then we can go entirely with the performance. Let's calculate strictly the shortest path so that the delay to go from one router to another router will be the lowest. Third reason, Yeah, separating internet routing to two levels is also to reduce the amount of memory requirement and to reduce the network bandwidth consumption. You see, intra-AS running link state there, the amount of global information much lower, right? Because you're only keeping the information of the local area network. Amount of link state reports you need to send also lower because the number of routers in the AS lower. Similarly, in the backbone, okay, these border routers, okay, the amount of it lower. Therefore, amount of updates we need to send lower. Okay, and there's prefix for the destination. Okay, the higher we can aggregate the prefix, the memory requirement for the pass factor also lower. So, separations of internet routing into two levels.
All right, so that's all for the semester. And hey, guys, I would like to draw your attention to Katie's solution. Okay. Katie says, yeah, again, Q1, Q2, just like many of you guys says. Okay, try to balance the deficit. But Q3 says this, ideally only B would know about CABX, so we make money, and C would only know about CBX, so we don't have to lose money. So essentially, wait. So I think essentially what Katie is saying is that A wouldn't know anything. A would just lose money. Isn't that right? Okay, so Polly's comment is brilliant, Katie. You belong in the business school. Okay, good. Guys, interesting, isn't it? Because we are seeing, having the full picture. We see that, hey, A is suffering. But A might not be able to pull the technical solution because they don't have the full picture. Okay, they can try to, plea for a better price, okay, to C, or ask B for a higher payment. But that's about it. Okay, A might not know. Okay, it's not good to block. Okay, CABX. All right, so that's all for the semester. With that said, I say goodbye and all the best with the finals. All right, bye. Okay, bye. Oh, thank you. Thank you. Oh, thank you.